Hey everybody, it's Mr. Greenwood again with another tutorial video. In today's video, I'm going to talk about how to factor trinomials, so three-termed expressions, in this special form using the box method. So here we go. What we're looking for is a special type of trinomial. It's got a squared term, a first degree term, and a constant term. So like v squared plus 11v plus 18. So we got a variable to the second power, variable to the first power, and then a constant or just a numerical term. All right. So in this pattern, we look for a couple things. So what I'm looking for is I want factors of this number. Okay, so things that multiply to give me 18. Okay, and then I want those factors also to add up to the b term or middle term, which is 11. Okay. So they have to multiply to give me 18 in this example, but they have to add or subtract. Add or subtract to equal 11b. Okay. Now this works when my coefficient on this is 1. When this is not 1, we follow just a slightly different strategy, which I would talk about in a future video. Okay, so now you'll see attached to the assignment there's a factor pairs chart. So I'm looking for multiples of 18 or factors of 18. So here's my factor chart. I have every number from 1 to 100 and the different ways you can multiply to get them. So for example, 4, I can multiply 1 times 4 or 2 times 2. So it's all the combinations. And it goes all the way down to 100. So feel free to use this as you do this exercise. So I'm going to flip back and look. I want 18. So I'm going to find 18 on my factor chart. My three combinations are 1 times 18, 2 times 9, and 3 times 6. What I'm looking for is a combination that will add or subtract to give me 11. So 1 plus 18 is 19, and 18 minus 1 is 17, so neither of those are 11. 2 plus 9 is 11. That seems good. 9 minus 2 is 7, so that's not what I want. 3 plus 6 is 9. 6 minus 3 is 3. So 2 plus 9 is my combination that fits. Okay. So I'm going to say that 2 plus 9 is equal to 11. And also 2 times 9 is equal to 18. So there's the combination we're looking for. Multiply to give you this, add to give you this when there's no coefficient or a 1 in front of that. So once we've done that, we'll draw our box. And we're basically modeling this by using area. And so each box represents an area, length times a width. So in the top left box is going to go the v squared from the expression. The 18 is going to go in the bottom right box. So we'll fill those in from this expression. And then these two are where the green is. And we're going to split this up into two parts. So we're going to split it up into 2v and 9v from this piece up here. So 2v here, 9v here. And from there, now we can do GCF to figure out our factorization. You can swap the 9v and the 2v. You can put 9v here, 2v here. It doesn't matter. Your answer will just look slightly different as far as which is where. These will switch places, but it's still the same. All right, so now we use some orange here. So the greatest common factor of v squared and 2v. So what do they have in common? They share a v. So we'll go horizontal, this one and this one. 9 and 18, I'll flip back to my factor chart. So 18 has 1, 2, 3, 6, 9, 18. 9 is 1, 3, 3, and 9. The largest number in these two that are shared is 9. So that means 9s are going to come out here. So that's this way. Now we'll go up and down. V squared 9v is going to be 1v or v. 2v and 18, we'll flip back to the chart. 2 is 1 and 2. 18, 1, 2, 3, 6, 9, 18. So they share 1 and 2. 2 is the largest, so it would be 2. Since both the green numbers are positive, both of these will be positive. So plus here, and when we write our final solution, we're going to say v plus 9 times the quantity v plus 2. Okay, there's a factorization. When you look at this second one, you'll see the numbers have to multiply to 8, but add to -6. So what you're looking for here is 2 times 4, but we want -6, so we're going to have -2 times -4 is equal to +8. I used the wrong color there. That should be red. And then we're going to go -2 plus -4 equals -6. Okay, so when I put this into the square here, same kind of process. R squared and 8 come from the expression. So there's my R squared, there's my 8, and now we're going to have negative 4R there, negative 2R there. Remember, these can switch places. And then my commonality will be R. Here it would be 2, but since this green one is negative, we'll make it a minus 2. Again, here we have R up and down, and then negative 4 and 8, so 4. Since this is minus, we'll make that a minus. And you can check negative 2 times negative 4 is positive 8. So our final solution would be R minus 2 and R minus 4. So the whole idea, you can check and say, hey, am I right? Did I do this correctly? If you double distribute back out, so R times negative 4, negative 2 times R, and negative 2 times negative 4, and then combine your like terms, you should get back to exactly where you started, okay? That is factoring trinomials, this special case, where we have a squared variable term, a variable term to the first power, and a constant term. I hope this helped. We'll see you in the next video. Bye.